Maruša, si slišala ta veter?
Ja, sem, meni kar zmrazil. Sem že kar gledala, iz katerega vogala bo kakšen pingvin skočil.
Ja, pingvin ni želel pred mikrofon, ampak sva pa se pogovarjali z avtorjem tega posnetka, ki nama je opisal, kako je v takšni skrajno mrzli in negostoljubni deželi preživel zimo in tudi poletje. Veter, ki smo ga poslušali, je namreč posnel na Antarktiki. In to ne kjerkoli, ampak ravno na Concordii, to je pa najbolj odročna postaja na antarktični celini, dobesedno na koncu sveta.
Wow, tam pa mora izgledati že tako kot na drugem planetu. Kaj ga je gnalo tja in kaj je tam počel, nama bo današnji gost, Daniele Tavagnacco, opisal v intervjuju.
Dobrodošli in dobrodošle torej v novi sezoni, že 6. sezoni podcasta Temna stran Lune, v katerem odkrivamo znane in manj znane plati astronomije. In tokratno sezono začenjamo torej na skrajnem robu Zemlje, kjer je mraz neizprosen, a nebo čudovito. Prisluhnimo intervjuju.
Today we are taking you to one of the most remote and extreme places in our planet, Antarctica. A frozen continent at the bottom of the world where temperatures drop far below anything we experience in everyday life and where international teams of scientists push the limits of human endurance and knowledge. Our guest today is Daniele Tavagnacco, an astronomer who's working at Trieste Observatory and who spent 3 seasons at Concordia station, which is one of the most isolated research bases in Antarctica, and it's located more than 1,000 kilometers inland. And there he worked as a support to the astronomical equipment at the station. Daniele, thank you for joining us.
Hello, thank you for inviting me.
So, to start with, going to Antarctica is related to a lot of complex logistics. It's extremely challenging to work there. Conditions are very extreme and not really exactly suitable for humans to live there. And it requires a lot of preparation. So how did you decide to go there and to take part in such a campaign?
So deciding to go to Antarctica, it's easy. You say, yes, I want to go. Having the opportunity to do so, it's a little bit more complex. You have to find several things that are okay with your actual life. For example, my first time I went to Antarctica, it was for an entire year. I spent 1 year in there. And so when the opportunity arrived, the question was, can I pause my life here and go there for 1 entire year? So that's the more complex part from the decision making. Mm-hmm. After the decision is done, it comes the really technical complex part, which is prepared to go to Antarctica. But that's all taken care from the day you say, yes, I want to go, and you apply to go to Antarctica. It's taken care from in my case, I went with the Italian Antarctic program, the PNRA. So all the aspects of the training has been managed by them. We did a lot of training for several staff, preparing for emergency that fortunately never happened, but we were prepared. And so basically deciding it's easy. Opportunity to do so, it's a little bit more complex, let's say. Yeah. In my case, I was finishing my PhD studies. So in there, I had this perfect occasion to pause my life, pause the activities I was doing here when I was studying astrophysics. So I paused my activities. And I went for 1 year to operate a telescope down in Antarctica. After that 1 year of experience in there, I come back to Italy, and basically I had no other occasions to go back to Antarctica, because coming back, defending my PhD thesis, then I start working on year-by-year contracts in the world of the research, let's say, as a first working experience in a research field, and you have year-by-year contracts, and those that not allow you to pause again your life and go back to Antarctica.
Yeah.
Can you tell us a little bit about the Concordia station? So where it's located, how does one get there? Because I believe that it's not so easy to get there, and when it was built, and actually why it's called Concordia.
Yeah. My activity was indeed in Concordia station, but I visited also other stations, research station, because Concordia station is located in the inner part of the continent, so is not directly reachable by any connection. So the first step to go to this base is to fly to Antarctica. And from the Italian program, going into Antarctica, let's say, can be done by, as I said, flying to there or by both. You can this research ship, and then in couple of weeks, sometimes it's good, so it's less, it's 7-8 days, you reach the Antarctica coast. Once you are there, you have an internal flight, let's say. I like to call it the Indiana Jones like flight because because it's done on a old, let's say, plane, old by design, not old by equipment. It's a DC-10 plane, I think, no, DC-3 plane. All prepared for the Antarctic conditions, and that flies you from the coast to the position of the base, which is more or less 1,200 kilometers from the coast. So it's a 4.5, 5 hours flight from the coast. To reach the coast, it's 7-8 days by boat if you are lucky with the meteorological condition, or it's let's say 8-9 hours flight by plane, which usually is handled by the military. It's a military plane because we depart. The Italian program departs from New Zealand, having as a starting base the American Antarctic program, which is handled by the military. So you have military planes to do that. Concordia. Why it's called Concordia? Because the base is not an Italian base. Is a French-Italian base. Is managed by both countries equally, and Concordia has been chosen as a name to, let's say, underline this cooperation that is going on in that base from these two countries. Italy and France, they have their own base on the coast, but they are joining their efforts in order to have a inner continent base, which is Concordia. This is open all year basically, and it's joint effort. That's the reason of the name, let's say, Concordia.
So this is a research station, which means that a lot of research is going on, and this includes astronomy. So what kind of astronomical observations do you do there?
The astronomy observations in Antarctica are related to the particular conditions that you have in Antarctica. To observe the sky in any part of the world, you need a few things. No light pollution from cities nearby. You need to have a clear atmosphere, possibly with low water vapor, in order to have a clear image of the stars or any astronomical object you are observing. And basically, you need the night. If you take these three conditions and you think about Antarctica, you have a place where there is nobody, so there is basically no light pollution, where the air is very cold, so you have a very, very low vapor of water in the air, so the sky is extremely clear to observe the sky. And depending on the period when you switch on your telescope, you can have up to 3 months of continuous night. So this means that you can observe the sky continuously without stopping your instrument because the sun is rising for 3 months. And this opens windows of observation for very particular objects that are studied there. For example, there is an ongoing experiment, which is several years it is there, that is studying transit of exoplanets. The exoplanets are studied by observing when they transit in front of their star. To do that, you need to observe continuously the star for a long period. The longer the period, the better the chance to observe the planet transiting, and the better the observation you can do, because you can see also planets that take long time to transit in front of the own star. So that makes Antarctica exceptional for this kind of astronomical observations. Other thing that you can do in Antarctica with telescopes is observing the infrared band, because the infrared band, so let's say the heat, infrared is just a different way to call the heat. It's a wavelength that it's very, very difficult to observe, because it's easily polluted by everything that is warm around you. So you need a very, very cold environment, because also the temperature that your instruments have, that can affect the observation you're doing. So let's say that Antarctica, that you can observe many things, but the best things to observe are things that need long time observation, so light curves of objects. They can be exoplanets, or they can be also meteorites, or they can be comets, or whatever. So you need long time observations, or you need particular bands, like the infrared band, that has particular requirements in terms of temperature and water vapor in the air.
And how many telescopes are there at this station?
In Concordia station, there are let's say big telescopes. There were two I used in the past, because the one in which I was working on finished its operation basically this year, and so it's not has not been renewed for the next year. So now there is one big remaining. For big, I mean a 40 centimeters diameter telescope, because the dimension of telescope is measured on their diameter, which is linked to the capability of collecting more light. The larger is the aperture of the telescope, the more light you can collect, so the more powerful, let's say, is the telescope. So there is this French telescope, which is a 40 centimeters telescope, which is dedicated to observation of exoplanet transits. And there was this telescope I was working on, which was called ITM, the International Telescope Maffei, which is an 80 centimeters telescope. So it's 4 times more light than the previous Aquarius. And this was dedicated to infrared and visible observations. Then there are also other telescopes that monitor the atmosphere, for example. Then during the, let's say, day, so during the summer period, there is also some on-the-spot experiments that bring a telescope to observe the sun, for example, because if you can see for 3 months the sky because there is no sun, vice versa, during the summer, you can observe continuously the sun for 3 months without having him going away. So you can monitor for long periods also our star.
And you said that you were working on one of the telescopes, the Maffei one.
Yep.
And what was your role at Concordia, and what kind of tasks did you have to do? Because I was reading some of the reports, and at some point I found that you also collaborated with other experiments.
Yeah. Okay. Yes. I mean, I on this telescope I covered 2 roles. When I first went to Antarctica, the first time I went there was 2013, so some times ago. I went there and I was an operator for the telescope. So my role was maintain the telescope operative, let's say, make sure that it works, because to be sure that it works also during the harsh conditions that you have during the winter. So very low temperatures, everything breaks during the winter. So you have to actually do everything. A person that operates a telescope, it's a little bit electrician, a little bit mechanic, a little bit astrophysicist, a little bit computer scientist. Depends on what's going on in there. So it's difficult to appoint one role. After that, for a few years, I was not able to go back to Antarctica because of my positions in here that did not allow me to leave the activity I was doing here. But I continue to follow the activities in there in my, let's say, spare time. And after that, I went back to Antarctica starting from 2021, so 4 or 5 years ago, as a technical manager for the telescope, meaning that the telescope changed its activity from the time when I went the first time to now. And we renewed all the equipment, and I was in charge of, let's say, supervise the activities of renewal of the parts of the telescope. And we redo the telescope from scratch using newer electronics, newer detectors, and stuff like that. So a little bit of everything is the answer. My role was a little bit of everything, as many people in Antarctica do, because in Antarctica it's very complicated to have one task only. You have to help everything you can, and you do everything that is need to be done, let's say.
How many people are there actually at this station?
In Concordia station, the answer depends on the period of the year. During the summer, when the base, let's say, is open to all the activities, there can be up to, I think, 80 persons can stay there, because there is the base, plus there is the summer camp, which are external parts of the base that are switched on only during the summer period, and then they are switched off during winter. Then there are external tents that can expand more a little bit the beds. Let's say the beds where you can stay in there, but the base can hold, I think, up to 80 persons. During the winter period, which is 9 months more or less, where the base is officially closed for the external operation, meaning that the people that are there remain there; they cannot leave, and the people that are not there cannot go into the base because the temperatures are so low that there is no way of reaching the base. During that period, you have a crew of, I changed the name because they are a crew when they are during the winter period. They are not persons or researchers, they are a crew. And they are around 12, 13 persons managing the whole base. So one for each task, let's say, expertise.
It's really a few.
Yeah.
Yeah, that's really a few. Now I see why people need to do everybody's for everything. You need to do everything. Yes. So you experienced the entire year, so both winter and summer seasons. So can you tell us, how does life look like there? So like your typical day, your social life, do you have any social events there? Because if you're there in the winter especially, it can be quite isolated.
Absolutely. Let's say that the typical day can be divided again into two typical days. One is the summer typical day, and the other is the winter typical day. During the summer, the life is chaotic. The base is open 3 months per year, and in those 3 months, everybody is there to fix their equipment, install new equipment, refurbish the base, refurbish all the stuff you need to survive the winter, is fixing everything. And so it's very chaotic. I mean, life is super fast, and you usually don't notice the time passing. You arrive, you say, okay, I have, I don't know, my experiment has been allowed to be in here in Antarctica for, I don't know, 20 days. I have plenty of time to do everything I need. You turn the corner and you find out that 19 days has gone. has gone. So it's very chaotic. There are a lot of events because there is, I mean, it's a very remote place, so to keep the spirit up between people, there are a lot of events, from basic ones, which is watching a movie all together, to more fun ones, which is having a party, everybody together, which is absolutely impossible to think in here to have a party, for example, at 9 p.m. with a completely sun up in the sky.
Yeah.
And you start this party, you party really hard for 2 hours, it's 11 p.m. and the sun is still up there. So it's complicated. But that's summer life. A lot of persons, a lot of activity, a lot of helping each other, because some experiments are a little bit in delay. For example, they can ask for help if someone is more forward with the activity. So there's always this helping stuff in Antarctica, which is very good. Vice versa, everything changes during the winter. When the last plane leaves, everything is like in a slow-mo. Everything slows down. Days are very, very long, because you come from a period where there was plenty of persons doing a lot of stuff into a period where there are 12, 13 persons, everybody doing his job. So you hardly notice sometimes people during the day, until there is a moment where you gather all together, which is basically when you have lunch, when you have dinner, or when you have a coffee half of the morning, depending if you are inside the base or at the telescope outside the base. Because once you dress up, you go outside, you reach the telescope, and for example, there is a coffee at 10:30 in the morning, you say, nah, I stay at the
Really?
telescope. It's warmer, I will be here. See you at lunch, guys.
Wow.
So life is slower during the winter.
Yeah.
You have plenty of time. You can do a lot of stuff if you want, because you decide your working schedule. You have the tasks performed, which is the usual task that you have been instructed during the summer, but you decide how to perform them and when to perform them. You have a lot of time that you spend doing what you like. In my case, for example, I like to cook, so I spent a lot of time in the kitchen with an actual cook teaching me a lot of stuff. So it depends. You can read, you can watch movies, you can go to the gym, you can write your PhD thesis if the last period you need to write your PhD thesis.
Something we didn't ask yet. So, how cold does it get outside? Because I was thinking, can you just go and take a walk outside?
Yeah, it's pretty cold. During the warmest period, which usually is around Christmas here in Italy, in northern places, the temperature rise up to minus 20. So during the day, let's say, during the day hours, because distinguishing day and night, it's only a matter of where is your clock positioning at,
Yeah.
because you don't distinguish by the light. I mean, if you learn where the sun is, you can distinguish by the light. But let's say during the day hours, it's minus 20, minus 25 in the warmer period. And during the night hours, let's say, it goes down during the summer. Best days, it's minus 30, minus 40. And then when the autumn approaches, the temperatures quickly fall down around minus 50. And then when there is the night period, you have a very large variation of temperature, because it depends a lot of on the coverage you have on the sky for clouds. I mean, clouds can really warm up the temperature for 20 or 25 degrees. So you can go from minus 30 to minus 60 in matter of half a day. And the coldest temperature I experienced was around minus 79, 78, stuff like that. I know that there is a record, but I don't remember how cold it was. It was nearby, not in Concordia. It was in a Vostok station, which is 600 kilometers from there.
Nearby.
I think it was minus 89 or stuff like that in the 80s.
Another question related to that. It's imagining to be there. So what would it look like if I want to go out So I have to really, put some extra clothes on me, and I don't have to put my nose outside. So what should I do to go outside with that temperatures?
The clothes are designed for the Antarctic environment. They are provided. You cannot buy them in the store. They are provided. In my case, I went to Antarctica with the Italian Antarctic Research Program (PNRA), and so they provide the clothes. There are specific for that base. For example, the base on the coast has a slightly different clothes because main difference between coast and the Concordia base is that there is no humidity. Having no humidity, it means that your clothes don't need to shield you from humidity. They just need to shield you from the cold. And also in Antarctica, there is in Concordia there is not so much wind. Let's say in the last years it increased a little bit, but it was chosen that particular position because there is almost no wind. So having no wind means that your clothes don't need to shield you from the wind. But as soon as the wind is up, everything changes. So you have dedicated stuff to dress on with. The typical clothes, they include boots, which are particular boots strongly insulated that can reach down to minus 100 degrees, and they still are soft, let's say, because the problem with the plastic is that when you go below minus 40, it becomes rigid and it breaks. So those boots are designed to maintain flexibility also at low temperatures. And then you have a sort of powered up mountain equipment, which has more insulation, and it works perfectly to shield you from the cold. But if you use the same exact jacket or hat in the coast where there is humidity, you suffer a lot more the cold because it's not designed to shield from humidity. So basically, you have your clothes, then you have some first layer of insulation, and then you have the second layer, which is the really big jacket and boots and everything. And during the summer, during the winter, the thickness of the jacket changes because minus 20 is really, really different from minus 80.
Yeah, I can imagine.
We believe you.
Yeah. What about, so you mentioned wind.
Yeah.
And in the introduction to this podcast, we've heard audio with wind, but I was surprised that there were no animals. I imagine Antarctica, there are penguins and animals. So, are there any animals there?
I mean, animals are smart. So they are on the coast. They don't try to get into the inner part of the continent because Antarctica is a huge continent. 14 million square kilometers, I think it is. Europe is 10 million, more or less, to give you an idea.
Oh, wow.
So animals, there are animals, but they are on the coast. On the coast, you have seals. I don't know how many kind of seals there are there. I'm not an expert. People will try to beat me because I don't know how many variation of seals are there. Then there are seagulls, which have a particular name there. They are called skua, which are sort of gray-brown seagulls, very nervous because we humans walk in between their nests. so so they have all the reasons to be nervous with us. And basically they are like that on the surface. Then in the ocean there are a lot of fish, a lot of life that I will not describe because they beat me because I don't remember all the name of the species that live in there. But there are a lot of animals, but on the coast. That's the difference. Penguins, there are a lot of varieties of penguins, but also on the coast.
Yeah, of course.
I've seen the penguins when I was passing by. So
nice.
I went there, I see the penguins, and then I take the airplane. I did my 4.5 hours to Concordia station, and then I never seen an animal for one entire year.
Sad. It's so sad. No animal, no plants, nothing. Is
No,
there? Speaking of plants, are there any like greenhouses or something to cultivate? I don't know, lettuce or some spinach or something to eat.
I mean, that's a complicated part because I'm not up to date to all the regulation in Antarctica, but there is this treaty on the Antarctica that specifies what you can bring and cannot bring in Antarctica. And as far as I remember, there was no possibility to bring stuff to be cultivated in there. But in the latest years, they're experimenting a little bit with, I think, hydroponics stuff. So there is some green stuff growing, but it's more an experiment than a real way of sustain the base. I mean, the base is sustained by food you bring once per year. Based on the coast or on the Antarctic Peninsula, they have more connections with the other continents, so they can bring stuff.
So most of the food is frozen, vegetables and things like this. You bring it there frozen?
Yeah, I mean,
Or you keep there and it freezes.
exactly. Let's say when there is fresh food, the chain of supply is really fast. I mean, the fresh food is brought during the summer season by plane, and as soon as the plane arrives, the food is unloaded by the plane and brought immediately inside the base before it freezes out. So it's very delicate operation if you want to have some green stuff to heat, let's say, or fruit.
Speaking about living there, so we are astronomers. How does sky look there? You said it's very, of course, there's no light pollution. It's super dry. There's a lot of darkness. So how does it look like? And there's also aurora.
Well, yes. I mean, the sky looks beautiful. It's an ideal place for an astronomer or for every person that loves to observe the stars and observe the sky, because it's a darkness that is difficult to portray. It's difficult to describe. I mean, it's a complete darkness on a complete white environment. So the few light that is coming from the stars, I'm not talking about the moon. That's another particular event. The light that comes from the stars, I mean, can help you see things around.
Really?
So, yeah.
Wow.
So there is a really nice sky. Then considering that we are in the southern hemisphere, and meaning that the center of our galaxy is in that direction when you observe the sky, our galaxy in the sky, it's really bright. You can see this bright line up, cutting in half the sky, let's say. And you can see by naked eye really a lot of stars. I didn't imagine that you can see so many stars by naked eye. When there is the moon, everything changes because you have the same effect you see in the pictures of the astronauts in the moon. I mean, you have this bright light that almost blinds you. You cannot see any stars or any star around. You turn your back and you see again the stars. It's incredible. And with the snow and the ice, which is really white, I mean, it's almost daylight. The full moon, it's almost daylight. And so yes, it's a super nice sky to be seen by there. Auroras are complicated because Antarctica, the Concordia base, it's really near the southern pole. meaning that the aurora is showing up in a circle which is a little bit larger than the position of the base. So it's really difficult to have the aurora exactly over you in a Concordia base. You can see it around, far away, like we can see also from these latitudes when some incredible event happen. We can see this reddish sky on the horizon. But to have a real feeling of an aurora, it's complicated from there because you need very strong auroras.
Amazing. So when I was preparing for the interview, I've read that Concordia is quite high. The altitude is quite high, and of course it's very, very dry. So you can actually already see some stars, even if the sun is still above the horizon. On the other side, you can already see some stars. Is this true, or did I just read something weird on the internet?
No, it's absolutely true. I mean, when I was saying that there is almost 3 months of complete darkness, it doesn't mean that you don't see the light coming from the sun, because at midday, more or less, if you look in the south, more or less south, you can see almost as if the sky is ready to sunrise. The sun is almost there. You have this faint light on the horizon, so actually it's not completely darkness. There is this very faint light, but you can see the stars. You can see them. And during the year, this from this condition of minimum illumination from the sun, it goes very fast through a daylight like days. So the day at the beginning is few minutes of light, then you have 1 hour, then you have a couple of hours, then for a week and a half, you have a normal day, let's say normal for our latitude. You see the sun going up, having a quite long day, then goes down, and then it stops going down, and it's always up. It goes down a little bit on the horizon, but it never go below the horizon. In this fast transition, you have some days where you can see the sun that is actually coming a little bit above your horizon, but on the other direction you can still see the stars. When you come out from the winter, usually the base is covered by snow and ice, and it becomes pinkish violet color of the base. I don't know if you've ever seen some pictures of Concordia base. If it's really pink and violet-like color, all the base, it's coming out from the winter.
Okay. Good to know.
It looks like on another planet, and actually, my question was somehow related to that, in the sense that you mentioned also before that during the periods when you are isolated from the rest of the world, basically you are alone or alone with a crew there. So there is a crew. So it reminds me of something like a space station, right? So Concordia is also sometimes called the White Mars, because it's remote and isolated, and also is used by space agencies to as an analog for missions to other planets. And do you know maybe what kind of research is done there that is connected to space travel and living in space?
Yes, I mean, I don't know exactly what research they are doing now, but on the winter crew, there are every year a set of experiments that are selected by the European Space Agency to be performed or carried on by the winter crew. Those experiments are, let's say, related, or they are studying particular conditions that can be translated into something happening in the International Space Station or any other space station later on. I mean, Concordia sometimes is called White Mars because of two things. First, there is no humidity, so you basically are in the middle of a desert with sand, but the sand is actually ice dust. It's super fun because you think is snow, so you take you grab this snow, you try to build a ball, and you cannot build a ball because it's actually more like sand than snow. It's very, very dry.
So you cannot build a snowman from that.
No, it's very difficult. It really needs a lot of expertise, and you need to mix up water and this sand-like ice in order to make them freeze together. And you can do any sculpture, but it's complicated.
So
It's
this
not
means that you tried it, right?
maybe. Yes, but you can build anything with blocks of ice. If you want to build any glue, you can do it. You have very, very big blocks of ice. You can sew them out from the from the pavement and go on. But going back to your question, it's also called white Mars because the isolation that Concordia has is stricter than the isolation of the International Space Station. I mean, being on the International Space Station is more dangerous because of the particular conditions of space. But being in Concordia is more complicated because if any emergency occurs, Concordia can rely only on the personnel, on the crew that is there, because it's not possible to evacuate the base. Uh, while on the International Space Station, you can, in extreme cases, you can evacuate the base, and in more or less 4 hours, you are back on Earth. In Antarctica, even if you are trying to leave Antarctica on normal conditions, you are not on the continent in 3 or 4 hours. You need at least, if everything goes smooth, there is no bad weather condition, every plane is there ready to take you and evacuate you. You take something like 14 hours to go out from Concordia Bay. So that's why it's called like that. It's completely isolated. The experiments they carry on are all related to the human behavior and human adaptation of this particular condition. In particular, during my staying, there were a lot of experiments studying the psychological effects of complete dark or complete light environments in terms of social interactions. So in my case, we had to keep a video diary every couple of days, I think, highlighting all the bad and good stuff that happened in there to see how our voice was evolving during the staying in there in order to address any psychological problem arising from this isolation. Then there were studies on the food. I think it was twice per month. We had to write down what we choose to eat on that day and why. To see if the choice of food changes with the no light or with the normal days or stuff like that. Then we had a lot of experiments on the sleep. We had a set of electrodes glued on us during the night to monitor our sleep and stuff like that, and then blood tests and stuff like that. All of them are voluntary based, so you are not forced to do the experiment. They ask you, since you are there, can you please help me in my research taking this stuff? You can choose, for example, I don't like so much needles, so taking blood was like, but I said, okay, then, I mean, I understand that it's important for you, and I will try to do that every month. But I mean, there are these kind of experiments. Then a lot of stuff on the reaction time. You have and you lose during the winter because of two factors: the isolation and the very low temperatures that diminish the quantity of oxygen you have in the atmosphere, because CO2 start to condensate at very low temperature. So you have a thicker layer of CO2 in the base, and everything slows down, also your reasoning. So they are doing all this kind of stuff like that.
Wow. So you've spent there really a lot of time and you have a lot of experience. Are there any anecdotes or some interesting stories that you would like to share? You already mentioned trying to build a snowman, but do you have more such stories?
I mean,
That can go on, right?
putting a lot of people crazy enough to go in Antarctica together, there are a lot of anecdotes that can, a lot of stuff that can happen. One of the less embarrassing one, it was during the night, during the night period of the 1 year I stayed in there. I like to work during the night hours. I mean, my 100% of concentrations came up during the, let's say, dinner time or late after dinner. And so usually also when I'm home, I start doing stuff and I go on. And at a certain moment I say, okay, I'm quite tired. I look outside and some days I can see some light coming up. And so I say, oh, today I did really late. Same stuff happening there. So as soon as the last plane left and we went on, I set my routine automatically on working, let's say, after dinner. After dinner, 100% of activity. It was super fun for me going on. And one day I was thinking, I'm quite tired. It should be late. But there was no light outside. Until one of my friends came up and said, "Oh, you wake up early today. You're already working here." People were coming from breakfast, and I was thinking if it's late, then I should go to bed.
Wow.
Maybe. Marusha, do you want to ask anything else?
Actually, I have one question that I wanted to ask before, but we discussed so many different topics. So you mentioned, you already described special clothes and how at very low temperatures the plastic clothes break and so on. But what about telescopes? You mentioned also that everything is breaking all the time, and I imagine that at such cold temperatures, things go wrong with the usual materials.
Yes. To give you an example, the laptop you are working with need a charger. A charger is a cable made in plastic. If you put your laptop and your cable in your backpack and you walk outside going to the telescope, for example, in the time you are outside, the cold start to affect this material. The battery of the laptop goes out very, very fast. But when you take your power cord to connect it back to your laptop, it's completely rigid. And if you start to straighten it up, it breaks. Usually you don't notice it breaking on the outside unless it's very, very cold, but it breaks on the inside. So the inner cables, they touch and you usually fry everything. That happens with any cable you have outside, for example. And the telescope, since it's moving, has a lot of cables, pending cables, cables on the pavement, cables below the telescope and stuff like that. So you need to use particular cables that are very expensive, or if you use, let's say, normal cables, which is cables made with very, very, let's say, very specific plastic, you have to be sure that they move the less possible. So you fix them in order to not move them around when the telescope, for example, is rotating, is pointing, or stuff like that. And you cannot walk on them because your boots can break the cable, for example. So it's very complicated in there. And then, since there is very low water vapor in there. Also, the convection, the convective flow of the air is very limited, and everything starts to heat up really, really fast. So you have to put fans in every electronic equipment to force the air to pass through. Because, for example, a computer can break because there is not enough ventilation. Because the computers here, they rely on a convection of the air. So the air moves because of variation of its density. But since there is no humidity, so basically not so much density to vary, the air is pretty much fixed where it is. So you have to force it to move. So everything breaks in the Antarctica. Everything.
Wow. So it's really like what we discussed before. It's another planet. Everything is different. Wow.
So Daniele, you are, if I remember correctly, active in the Euclid Consortium, right?
Yes.
And beyond the research and the technical work, both for the space telescopes and also, I mean, for the Antarctica ones, at least until this year, right? So you're also active in the association that I believe that you founded, the Science Industries. And I was wondering what is this association working on, and if you can tell us about some of the projects you are involved in.
Okay. Yes. I mean, yes, I'm currently working as a member of the Euclid Consortium. Euclid is an ESA mission, space mission, and in there I'm working using modern terms as a data analyst, meaning that I wrote code to analyze the data. This directly affects the second part of the question, which is what is science industry? Science industries is something that came up years ago with a lot of with some friends I was working with in Trieste Observatory on another space mission. But it's a necessity we had since we spend the whole day writing code. We rarely talk to people. So we said, why don't we start an association where we explain what we do by job in our jobs, and we have the occasion to talk with real humans, not only with computers. And so this is the funny way in which Science Industries, which is a scientific animation association, was born. What we do is basically build funny mechanism to teach some basic physics to the general audience. Also schools, for example. So we build, I don't know, for example, a rover that you can drive with a laptop that mimics the distance between here and another planet. So you can experiment what's like to drive a rover, a car, in another planet, for example, Mars, and people learn why they go so slow, why they move a few centimeters per minute, and they are not going full throttle, because you have the delay of the commands on the images you see, and it's very difficult to drive it. So this kind of games to explain physics. And I mean, and we prepare presentation, we discuss stuff, we discuss about what we do in our job, our research lines, and stuff like that. So we need to talk. That's the.
So one thing, you are working during the night, so coding during the night, and then during the day you are doing talks and explaining to people what you're doing.
Yes, exactly.
In the night.
And driving space
When
rockets.
it's late in the night, usually the day I spend some hours to understand what I brought the night before.
Yeah, happens to everybody.
So I believe a last question is, what do you suggest to young people, maybe students that want to do such an experience in Antarctica? Where should they go? Where should they ask for some information or get the information about those possibilities?
It's very, very interesting, this one, because all the national programs for Antarctica, for example, in my case, I refer to the Italian program for Antarctica. They have web pages where you can find all the informations and where they put every information regarding some vacancies they have for activities to be performed there. Because when I went to Antarctica, I went on a research project based on a proposal of some research activity. But there are a lot of expertise needed there. They're not only linked to the research. For example, they need electricians, they need mechanics, they need cooks. And if someone wants to, is interested to go to Antarctica, they should keep an eye on all the web pages of the national programs for Antarctica, depending on the base they are looking for. If they are looking for the Concordia base, there are two Antarctic programs to search for, which is the Italian and the French program. But this does not mean that you are excluded if you came from another country, for example, and you propose an experiment linked with the research program of Italy or France for Concordia, as an example. So keep your eyes open on the web pages of these scientific programs in Antarctica. That's my suggestion.
Thank you, Daniele. It was really, really nice and really interesting to hear about your experience. Actually, it was really amazing.
Thank you, and I hope
to have
that
you.
the questions are more interesting than scary about the activities in there. But
Thank you very much.
Thank you.
No, tokratni intervju, kot ste poslušali, je bil namenjen Antarktiki. In kot nama je Daniele tudi posebej povedal, ne, je na Antarktiki ima Italija, italijanska država, več različnih, dajmo reči temu, postojank, ne, od te postaje, ki pravijo Concordia, do baze Mario Zucchelli, ki sicer ob morju, potem pa še uporabljajo pa tudi ladjo Lauro Bassi, in to znotraj programa, ki se imenuje PNRA in ki ga bova dodala v zapiske, če bi slučajno kdo si želel malo več pogledati. To je pa državni program raziskovanja na Antarktiki.
No, in sicer je Italija na Antarktiki prisotna že več kot stoletje in danes jo pa s tamkajšnjimi bazami povezuje ladja Laura Bassi, ki je pravzaprav ledolomilka. No, in ravno to soboto, 4. oktobra, mi dve namreč to snemava 2. oktobra, se pravi 2 dni prej, bo ta ladja izplula iz Trsta. Zdaj je zasidrana v Trstu in odšla bo na svojo že 41. misijo proti Antarktiki. Ta ekspedicija bo dolga in zahtevna, celotna bo trajala kar 7 mesecev. Raziskovalci pa bodo v antarktičnih vodah preživeli več kot 90 dni, torej več kot 3 mesece. Tam bodo zbirali podatke o ledu, oceanu in podnebju. In ena zanimivost, ki sem jo prebrala na Wikipediji, je naprimer ta, da v okviru tega projekta, to je evropski projekt zbiranja ledu na Antarktiki, ki se imenuje Epica. No, in iz teh vzorcev so ugotovili, da se v zadnjih 800.000 letih koncentracija ogljikovega dioksida v ozračju ta koncentracija nikoli ne presegla vrednosti v današnji industrijski dobi. Torej je bila manjša. Tako da to je recimo eden izmed načinov, kako so pokazali, da je CO2 danes višji v industrijski dobi. No, in tako so marca letos ponovno vrtali led in tokrat so ga izvrtali z globine skoraj 3 kilometre in potem se je skazalo, da je ta led starejši od 1,2 milijona let in to je najstarejši vzorec ledu, kar jih imajo in verjetno bodo ali pa so že ponovno izvedli te raziskave o podnebju v preteklosti. No, in zdaj povezava z ladjo Laura Bassi pa to, da je bila ravno ta ladja tista, ki je vzorec ledu direktno iz Antarktike pripeljala direktno v Trst. In potem so jo naprej pripeljala v druge inštitucije in tako naprej. No, ampak da ne zaidem preveč, še po kom je ladja poimenovana, Laura Bassi. To je bila italijanska znanstvenica iz 18. stoletja in ona je bila prva ženska na svetu z doktoratom znanosti in druga ženska na svetu z doktoratom. Hkrati je bila tudi prva ženska na svetu, ki je vodila katedro na katerikoli univerzi, in sicer je to katedra za eksperimentalno fiziko. Potem postala je pa tudi hkrati profesorica fizike na univerzi, in to je bilo v Bologni. To vse je bilo v 18. stoletju in to je bilo v času in svetu, kjer je bilo znanstveno raziskovanje skoraj izključno moška domena. In ladja, ki torej nosi njeno ime, zato odpira novo poglavje v raziskovanju najbolj odmaknjenega in skrivnostnega kotička našega planeta, o katerem ste ravno poslušali.
Če vam ni do večtedenske vožnje z ladjo do Antarktike, se lahko zapeljete do Trsta. Tam namreč domuje Italijanski narodni muzej Antarktike. Muzej Antarktike torej je prisoten v Trstu, ampak Trst skupaj z dvema drugima mestoma, torej Sieno in Genovo, je v bistvu lokacija, kjer se zbirajo različni eksponati, tako zgodovinskih kot tudi ostalih znanstvenih odprav. V bistvu v tem muzeju hranijo in prikazujejo tudi zgodovino raziskovanja antarktične celine ter vseh raziskav, ki so bile narejene na področju geologije in morske geofizike, ki so jih pač italijanske odprave naredile. Poleg tega pa imajo še poseben poudarek na 3 pionirjih, pač najtežjih in najzahtevnejših kopenskih osvajanj človeštva. To so Robert Falcon Scott, Roald Amundsen in Ernest Henry Shackleton. V tem muzeju najdete, ki je sicer nekoliko manjši muzej, ampak zelo, zelo zanimiv za ogled, najdete tudi italijanske odprave od začetka 20. stoletja pa do vse do najnovejših, ki jih pač organizirajo znotraj tega državnega programa za raziskave na Antarktiki.
Iz Antarktike pa direktno v vesolje. Vrača se namreč podcast z zanimivimi novicami v vesolju, portalu Vesolje. Na spletni strani kozmolab.si najdete povezave do portala v vesolje in portalovega podcasta, kjer kozmolabovec Jure Japelj objavlja zanimive novice v vesolju in astronomiji.
Ob koncu tokratne epizode pa si poglejmo, kaj lahko na nebu opazujemo ta mesec. Kmalu po izidu tega podcasta, 10. oktobra, bo Luna v neposredni bližini Plejad. Plejadam drugače v slovenščini pravimo tudi gostosevci. Luna bo takrat precej svetla, ker je to šele 3 dni po ščipu. V resnici bo pa tudi zakrila Plejade, vendar se bo ta dogodek zgodil podnevi, tako da te okultacije ne bomo opazovali. Če pa pogledamo planete, bomo v tem mesecu planet Venero opazovali ob zori, Jupitra v drugem delu noči, nekje približno na vzhodu, Saturna pa lahko opazujemo skoraj celo noč. Saturn bo med drugim kasno zvečer viden nekje v smeri jugovzhoda. V tem obdobju lahko na Saturnu pač opazujemo Saturnove obroče, ki jih gledamo s strani. Še par zanimivosti je potrebno omeniti, in sicer oktober bo, upajmo, da zanimiv mesec tudi za navdušence nad kometi. Z nekaj sreče bosta konec meseca s prostimi očmi vidna kar 2 kometa, in to na istem delu neba. Prvi C2025-6 Lemon, ki se imenuje Lemon po gori v Arizoni, kjer so ga prvič opazili, je trenutno, torej govorimo na začetku oktobra, z daljnogledom viden na jutranjem nebu tik pod velikim vozom. Sredi oktobra meseca pa bo postal bolje viden zvečer, ko se bo pomikal mimo zvezde Alfa lovskega psa in bo na meji vidnosti s prostimi očmi. Po ocenah naj bi največjo svetlost dosegel konec oktobra in začetku novembra, ko naj bi bil viden s prostimi očmi, in sicer v zvezdju Kačenosca, tik nad jugozahodnim obzorjem, in to po sončevem zahodu. Drugi komet pa nosi ime C2025-R2 Swan. Je še posebej zanimiv, ker so ga odkrili pred manj kot mesecem dni, 11. septembra, ko je bil že zelo svetel. Bil je 7. magnitude. In to pomeni, da so ga odkrili v resnici zelo pozno. Zaznali so ga na slikah vesoljskega teleskopa SOHO, ki opazuje Sonce. Komet v tem trenutku, ko snemava podcasta, torej v začetku oktobra, je viden z daljnogledom iz južne poloble, ampak naj bi obstaja torej verjetnost, da bo tudi ta komet konec oktobra postal viden s prostimi očmi, na nebu pa bo ravno tako v ozvezdju Kačenosca, tako kot Lemon. Torej, konec oktobra z nekaj sreče bosta na večernem jugozahodnem obzorju s prostimi očmi vidna, mogoče seveda kar 2 kometa. Torej, upajmo, da bodo opazovanja uspešna, ker je namreč svetlost kometov pogosto nepredvidljiva in zato pač trenutno imamo na voljo le približne ocene, ne pa točnih napovedi. Če bo svetlost sledila ocenam, se lahko zgodi, da bo komet tudi veliko svetlejši ali pa njegova svetlost ne bo nič posebnega. Držimo torej pesti, da se napovedi uresničijo. Če bi pa radi izvedeli kaj več o kometih, vas vabiva k poslušanju lanske oktobrske epizode, v kateri nam je Rok Nežič predstavil te kepe skal in ledu, ki prihajajo iz zunanjih predelov Osončja. Povezavo dodajava v zapiske.
Z vami sva bili Maruša
In Dunja.
in to je bila prva epizoda 6. sezone podcasta Temna stran Lune. Nasvete in vprašanja sprejemava na naslov podcast.temnastranlune@gmail.com, podcast pisano s K-jem. Poiščete pa naj jo lahko tudi na družbenih omrežjih. Podcast je praktično povsod z imenom Temna stran Lune in to je napisano vse skupaj brez presledkov.
Če želite, lahko podcast tudi podprete in sicer na strani ko-fi.com. Torej ko-fi.com, poševnica Temna stran Lune. Hvala vsem, ki ste to v preteklih sezonah že storili. Nabrani prispevki bodo služili nakupu opreme od mikrofonov do slušalk.
Podcast je del mreže aktivnosti Zavoda Kozmolab, ki se ukvarja s promocijo in popularizacijo astrofizike. Hvala Beliju iz sosednjega podcasta, opravičujemo se za vse nevšečnosti, ki je prispeval glasbeni uvod in zaključek.
No, na koncu še namig za naslednjo epizodo. Naslednjič se bomo malo zavrteli. Se slišimo čez mesec dni.
Adijo!